Let us take one more example. Find pH of 10 to the power minus 9 molar nitric acid solution. See, now the H concentration is 10 to the power minus 9 from nitric acid and 10 to the power minus 7 molar from water. If we compare this, this is a very small number, that will be second place of decimal. So we neglect this. So what we have is 10 to the power minus 7 molar H concentration. Therefore, the pH in this case will be minus log of 10 to the power minus 7. So it will be 7. So that is how we say the pH never goes beyond 7, because if it is very, very less than this one, we neglect the concentration of the H concentration which are provided by the acid added, and we only take those of which are available from the water. So between 10 to the power minus 6 to 10 to the power minus 8, we add the concentration of H which are obtained from the water. Before, even if it is the concentration of the H obtained from the acid is from more than 10 to the power minus 6, we neglect H concentration of water. If it is beyond 10 to the power minus 8, less than 10 to the power minus 8, we neglect H concentration of the acid, and that of the water as taken as this one. Let us take one more example which will give you the idea about the OH concentration in a similar case. Let us take now the example of a base whose concentration is between 10 to the power minus 6 to 10 to the power minus 8, and in that case we have to add the concentration of the OH ions which are already available in the solution from the water. Now the question is, find the pH of 10 to the power minus 7 molar NaOH solution. See, we usually have, in a hurry, we always know this. Fine, if this is 10 to the power minus 7, definitely pH will be 7. It's not like this, because there is a general formula also, that the pH is equal to 10 to the power minus, it's like this. It's like that the H ions concentration is 10 to the power minus of pH, and the OH ions concentration is 10 to the power minus POH. So we normally say it is like this. So we know if it is 10 to the power minus 7 molar, then definitely pH will be 7 or POH will be 7. It's not like this. It's not always like this, because here these formulas will not work. They only work when the concentrations are very high. In this case, we know the OH ions concentration is 10 to the power minus 7 molar. It is from the NaOH. But in that case, remember, almost the same quantity of OH ions are also available from water also. So we have to add both of these. And when we add both of these, it will be how much? 2 into 10 to the power minus 7. This is what is your OH ions concentration. If the OH ions concentration is this much, we can find out what is the POH is. It will be minus log of 2 into 10 to the power minus 7. It will be how much? It will be minus log 2 minus log 10 to the power minus 7. So it will be 7 minus log 2. It will be 7. Log 2 is 0.3010. So it will be 6.0996. So this is what is your POH. If POH is this much, therefore pH will be 14 minus 6.6990. So this, remember, this will be 7.3010. So this is what is your POHs.